In this lesson, we will examine in detail the procedures an air traffic controller operating a radar service must follow. Before a radar service can be provided, the identification of an aircraft by the radar service has to be established, and the pilot informed of the fact. From then on, radar identification has to be maintained until the termination of the radar service. If positive identification is lost at any point, the pilot is to be informed and alternative arrangements made. Radar identification can be established by either using primary surveillance radar, PSR, or secondary surveillance radar, SSR. Being more sophisticated, secondary surveillance radar is generally used as the preferred means of identification by controllers, simply because it provides greater detail to the controller for easier identification. Remember that secondary surveillance radar works by sending interrogation radar signals to aircraft transponders. These interrogation signals specify the type of information a replying transponder should send. For example, aircraft flight level, speed, heading, etc. Where secondary surveillance radar is used, aircraft may be identified by a radar controller by using any one of the following methods. Recognition of the aircraft identification in a radar label. This radar label is usually a code assigned to the aircraft, which is derived from its call sign or flight number, and is displayed against the aircraft position on the radar display, an example of which is shown on screen. Recognition of the assigned discrete code as verified by the radar label. This discrete code is the unique code which is assigned to an aircraft by an air traffic controller, and is commonly referred to as a squawk code. For example, if the controller assigned the squawk code 2164 to an aircraft, and the pilot set this code into the transponder equipment, then the squawk code would be shown on radar display like the one shown here. Direct recognition of the aircraft identification of a Mode S equipped aircraft radar label. Mode S secondary surveillance radar is unique in that it identifies the unique 6-digit hex code assigned by ICAO to the aircraft upon manufacture. This identification code is not displayed to the controller, but is converted to another recognizable label. This label is either the assigned label for that flight, the flight number or call sign, as shown here. The last three ways that an aircraft can be said to be radar identified is by transfer of an aircraft and its radar label from another controller, by a controller asking a pilot to set a code and observing that code as it appears in the display, and lastly, by compliance with an instruction to squawk ident. When a controller asks a pilot to squawk ident, the pilot will then push the ident button on the transponder, which causes the aircraft's position on the radar display to intensify, making it easier for the radar controller to identify its location. This completes the procedures used when utilizing secondary surveillance radar to establish radar identification. The other procedure for establishing radar identification is by using primary surveillance radar. Without secondary surveillance radar, aircraft can still be identified by primary radar, but the process is a little more difficult. Remember that primary radar operates using traditional radar principles, transmitting radio pulses, and listening for and timing the reflections. No other secondary data is returned that pertains to the radar target return. When using primary surveillance radar, aircraft radar identification can be established by at least one of the following methods. Firstly, by correlating a particular radar position indication with an aircraft reporting its position over, or as bearing and distance from, a point displayed on the radar map, and by ascertaining that the track of the particular radar position is consistent with the aircraft path or reported heading. This point can either be a geographical point or a reporting point. For example, an aircraft might report it is 2 miles north of the Delaware Ridge heading west. From the display shown here, the controller can easily identify the aircraft. The second way is by correlating an observed radar position indication with an aircraft which is known to have just departed, provided that the identification is established within 1 nautical mile from the end of the runway used. The third way is by the transfer of radar identification from one controller to another, under direct communication between the two controllers. The final method is by ascertaining the aircraft heading, if circumstances require, and following a period of track observation, instructing the pilot to execute one or more changes of heading of 30 degrees or more, and correlating these movements to a radar target. A controller may request that a possible radar contact repeat manoeuvres as many times as necessary to confirm aircraft identity. A number of times throughout this lesson, it has been stated that it is possible to transfer a radar identification from one controller to another. However, it is important at the outset to understand that the transfer of radar identification from one radar controller to another should only be attempted when it is considered that the aircraft is within the accepting controller's radar effective range. The methods used to transfer radio contact are designation of the radar position indication by automated means, provided that only one radar position indicated is thereby indicated and there is no possible doubt of correct identification, notification of the discrete code of the aircraft, direct designation, pointing with the finger, of the radar position indication if the two radar displays are adjacent, or if a common conference type of radar display is used, designation of the radar position indication by reference to or in terms of bearing and distance from a geographical position or navigational facility accurately indicated on both radar displays, together with a track of the observed radar position indication, instruction to the aircraft by the transferring controller to change code, and the observation of the change by the accepting controller, instruction to the aircraft by the transferring controller to squawk ident, and observation of this response by the accepting controller. This completes the methods by which air traffic controllers transfer radar-identified aircraft. You may recall that upon initial radar identification of an aircraft by a radar controller, the pilot is to be informed of his position. However, there are 4 other circumstances when a pilot should be informed of his position. The first is when a pilot requests his position information. The second is when a pilot's estimate differs significantly from the controller's estimate. The third is when a pilot is instructed to resume his own navigation after radar vectoring has diverted the aircraft from a previously assigned route. And lastly, an aircraft's position report should be given immediately before terminating a radar service. When a controller passes position information to an aircraft, the position information must take on one of the following forms: be in relation to a well-known geographical position, as a magnetic track and distance to a significant point or navigational aid, as a direction and distance from a known position, as a distance to touchdown for an aircraft on final approach, and lastly, as a distance and direction from the centerline of an air traffic route. Most aircraft are able to navigate along designated flight paths all the way to their destinations more than adequately. However, at major air traffic hubs, such as the confluences of airways or the arrival and departure catchment areas of major airports, radar controllers will directly control aircraft position and track. This is called radar vectoring. Radar vectoring will take place within the vicinity of aerodromes in specific areas. A radar vectoring area will be shown on various aerodrome charts and documentation, found in the aerodrome section of the Aeronautical Information publication. An example of a radar vectoring standard arrival area is shown here. This area will have been surveyed for obstacles, and minimum altitudes will be specified for each sector of the area. Minimum altitudes will be high enough to minimize the activation of aircraft ground proximity warning indicators. But should such systems be activated, then states must encourage the operators to report them. This will help prevent reoccurrences. Radar vectoring is achieved by the controller issuing simple heading changes to the pilot, which enable the aircraft to maintain the desired track. For example, Speedbird 559 turn left, heading 065, and descend to flight level 50. When vectoring an aircraft, a radar controller should comply with the following sets of important procedures. Firstly, aircraft should be vectored along tracks or routes that enable the pilot to monitor the aircraft position using his own navigational aids. Secondly, when an aircraft is given a vector diverting it from a previously assigned route, the pilot should be informed, unless it is self-evident what the vector is to accomplish, and, when possible, the limit of the vector should be specified. For example, to position for a radar to ILS approach to runway 26 left. Aircraft will not be vectored to within 2.5 nautical miles of the limit of the controller's airspace. If the radar separation minimum to the boundary of the airspace prescribes that a distance of greater than 5 nautical miles must be adhered to, then the closest a pilot will be vectored to is half the prescribed distance. Controlled flights shall not be vectored into uncontrolled airspace except in cases of emergency, or to circumnavigate extreme weather conditions. There are numerous occasions when radar vectoring is used other than for specifically guiding aircraft directly in or out of aerodromes. For example, when an aircraft is observed to deviate significantly from a route or procedure, the controller will inform the pilot and give the required corrective navigation. There may be occasions when pilots specifically request the controller to provide radar vectors. This might be to avoid bad weather, or the loss of navigational instruments might result in a request for vectors to assist in navigation. In such cases, the pilot must inform the air traffic controller of the reason, be it weather-related or due to unreliable ground navigation equipment. With regard to weather problems, if the controller sees that it is likely an aircraft will penetrate an area of adverse weather, then the controller should issue this information in due time, and if required, issue advice to best circumnavigate the hazard. When radar vectoring comes to an end, the controller will instruct the pilot to resume his own navigation, give him his position and any new instructions he may need. For example, Speedbird 55, proceed direct to Lima Bravo Whiskey, then resume normal navigation.